Okay, because it is many, all the micro program can be performed parallelly. Of course, kalau you ada satu je, you nak buat macam mana, right? If you have only one, of course you cannot do it parallel or sequentially. It is only one, and also maybe it is few, so normally it can be sequentially. And yeah, of course you can also do it parallelly, but in terms of many, to reduce time and so on, you are allowed to do parallelly, to perform it parallelly. While for vertical, the easiest way to you to differentiate is vertical is normally single, and only few, maybe two, maybe one, maybe three only on the micro operation. So it can be performed specify which is only a single or a few. So now you can see horizontal is many. So many micro operations that are available. Maybe you have 8 move, div, and others a lot instruction, which is called as a micro instruction in one single instruction. So there is a lot of micro operation, but if vertical you have only one. In single instruction, you only have one single micro instruction, or maybe one or two step only. And you can see over here, this is the format. Last time you tengok header format for you punya numbering, right? So here you have the format for horizontal and also vertical micro instruction. So for horizontal, you can see what is header that available in all the box for this format header. So you have a micro instruction address. So over here it is for address. Jump condition, you have several conditions that you can use for jump condition. Later on you will see several names that are specific for all of this. And then you have a system bus. And lastly, your internal CPU control signal. While for vertical, you have the micro instruction. Same go to your vertical. Your micro instructions at the end, the most less bit. So the on your most right is going to be the address, both for vertical and horizontal format under micro instructions. And second is similar also, which is jump condition. Of course, you can have few, and after that you have a function code. So all of this is a function code. You need to remember all the box. What is the elements for each box? Either it is under horizontal or for vertical. That's why you need to like memorize it. So here in this picture is the computer hardware configuration. I don't think that you need to remember it one by one, but if you always look into it, you can memorize what is all this block for. So marks you already look, I guess, in digital logic, and then AR, PC, uh, in your earliest module 5, your memory, your SCDR. So you can see how they are connected and correlate between each others. Of course, it was like hard for you to memorize it first, but when you are familiar, especially for your CU, because you're going to go deeper and deeper, and you going to be understand more in your control unit. This one I think is not yet touched, especially on your memory, because we're going to cover our memory and we're going to go deeper in our module 6. But basically this is one of your CPU. That's why you have ALU here, you have your register, and you have your control unit. Okay, now we're going to see some example, especially for this, which is our micro instruction format. How the question will ask you, because you say, okay, this one is just in terms of formatting. If I remember, is it? I just need to fill the blank fields, or maybe how the question will be look like. So later on I will show you how the question will be given in terms of this formatting micro instruction. Okay, you need to see over here, okay? You have instruction format. This one you already know. This instruction format form you already know. You can see over here, this is for 16-bit. If your instruction is 16-bit, because it's also depend on how many lang that you are using, whether it is byte, whether it is words, and so on. So this one is example for 16-bit, and you're going to see you have the indirect address at the beginning of your MSP. So here on your left is going to be indirect address, and it is only 1 bit. And for your opcode, it's going to be normally can have 4 bits. 4 bits. Your opcode, again, it is a operation code. Operation code normally your operation lah. You punya add, you punya multiplication, you punya move, what else? Multiplication, add, sub, and all other operation. So all of this will change into a code. So it called as the opcode code. See, opcode code. Although it's already opcode, then it's going to be a code again. So this one is opcode. When you change this into a code, which is like having 4 bits, you can have 000, 0001 until 1111. So you can have many operations in between also. And because you already occupy 1 and 4, you have 16 bit. That's why your address will be 11 bit. You tambahlah 1 plus 6 plus 11. How many you will get? Sorry. 4. 16 bit. And this is only sample. Sample, which is example, if you have 4 instructions in the program. So let's say you have additional operation, you have a branch, you have a store, you have an exchange. This one you already look into your lab too. So it going to change it into opcode operation codes. And then you're going to see you have the description for all of this. Let's say for add, if you still remember at your lab 2, you need to write a description. Maybe you are writing it in terms of wording, in terms of sentences, so it's going to be easy to understand. But over here it's described also, but in terms of like most on symbols. So you can see you're going to add, and what is the description for all of the operations that are available in your computer, in your program. So this is under instruction format. As you know, your instruction you have a program, and then inside your program you're going to have several instruction, and then after that, of course, you're going to have the operation. What is the operation? You can ask also several, which is fetch, and then execute, indirect, and interrupt. So let's say this is one operation, and under this operation instruction, you're going to see this operation, you're going to divide also into several micro instruction. So let's say this is another one micro instruction. You're going to have the format for this. So this one will be looking like this for the format for micro instruction. So when you can see over here, you need to see this F1, F2, F3 normally are fixed in your most of your left side. So first F1, F2 and F3, which is micro operation fields. And then followed by your CD, branch, and another one, lastly your address field. You need to remember the length of the bit. That's why after this you're going to see the table, how the table look like for F1. You're going to have 3 bits. That's why you're going to have 0000001, 010 until 111. Same goes to F2, 000. This one is the 3 bits, 0001 until your 111. F3 also similar. And you're going to see you have 2 bits for your CD and BR. If you have 2 bits, you're going to have only 4 possibilities, 0000001, 10, and also 11. How are you going to measure if you were given with the bits how many and how many possibilities that you have? It is to the power of n. N is your bit. To the power of 3 is going to get 8. To the power of 2 is going to get 4. So you're going to see here, this is all for your vertical micro instruction format. Okay, you're going to see 1, 2, 3, 4, 5, 6, 7, 8. So add possibilities for your micro operation. Add micro operation that can available in your F2. Same goes to F3. So this one is on the floor. What micro operations that available, especially in your programming? So micro instruction field description for F1, F2, and F3. It's already give you the tables. And you can see also CD and BR also have their own format of the table for micro instruction field description over here. So the condition for branching. So this one is CD, and you're going to see you have 0, 0 for always 1. If your condition is always 1, then what is symbol that you can use and what is the task and specification for 0, 0 for 0, 0. And you can see also you have the BR table, the type of branch to be used. So later on, I guess this table will be given or not. I'm not sure. Depending on what question will come out into your final exam. Over here, there is a example on how the question will be look like. So let's say you were given with micro instruction with 2 simultaneous micro operation. So simultaneously, you're going to know what is the type, and you're going to see only 2. So you need to find for DR. If I look here, it is at this, which is your read instruction. And then after that, your PC it as your F3, which is 101. So when you want to change it into your format, you're going to see that ignore first this one. Okay, kenapa dia keluar dulu? Okay, you can see you have only 2 simultaneously, and you can see there is no F1. If you still remember the format, you have F1, F2, F3, and then you're going to have CD, AR, and address, isn't it? But we look first this one. So as F1 is not available here, you go back to your F1 tables. If there are none for F1, you're going to put 0, 0, 0. So what will happen to my format table over here, header? You're going to see I'm going to put 0, 0, 0 for F1 because there are none F1 in my micro operation. For my F2 is going to be 1, 0, 0. And then for my F3 is 1, 0, 1. And later on, we will see in our next slide for our CGAR and also address. But address is not going to see basically in in your computer, in your question it will give you the initial value of the address. because different device, different machine is going to be started with different address normally. So you can see over here, F1 is 000. And those your vertical micro instruction field will be F1, F2, F3. And what is the format? It is going to be 000, 100, 101. And the rest other, your CD and your BR is showing here. Later on, you will also need to put in. So this is how you justify which is F1 is known, F2, and another one is F3. So it is not too hard. Basically, you can just refer your the table. No more than 3 micro operation can be chosen for a single micro instruction. So it is not too many, right? Here, you can see there is a table for your CD and BR. Same goes to previous one. You can see, okay, this one, this table. It is for your CD and BR. This is partial symbolic for your micro program. You can see if you have the levels of add, what is micro operation that can available, uh, what is the symbol for CD, what is the symbol for BR, and how about your address, whether it is direct, indirect, you jump or next, and so on. When you want to come out with the table, let's say for each of the micro operation, you will change it into in terms of the codes. You can see over here, all is going to change into the codes. So let's say I give you just example, let's say this one. So you will come out with this code, combination codes. So this is the micro instruction in terms of the codes or a binary form. So this micro program can be implemented using your ROM. Your ROM, your RAM, later on you're going to look into our module 6. So another example. So this one is on calculation. You have several type of question that can be asked in terms of this just format. And here is example for your calculation. Let's say you were given with the details. A system use a control memory of 10 1024 and you have 32 bits. So you already were given with the hint for 32 bits. And your micro instruction has 3 fields and 16 bit for your micro operation. So how you going to divide? You already know 16 bit for your micro operation. You have another 16 bit. Altogether, you have 32 bits. So let's take a look what the question asking for. How many bits are there in a branch address field and the selection field? If there are 16 status in the system, how many bits of the branch logic are used to select a status bit, and how many bits are left to select input and multiplexer? So here is the solution. That's why you need to have the keywords. You need to find the keyword first, like 1024. 32 bits, 3 fields? Yes, 3 fields, and also 16-bit micro operation. So you have 16-bit for your micro operation, and because you have 3 field, there is another 16 bits. Altogether is 32 bits. So you need to put like this, but you still not know what is the length for your select and also your address. You just know first, in terms of the information here, it is a 3 field. So you have 1, 2, 3. And over here it's already mentioned it is 16 bit for your micro operation, and altogether is 32 bits. And in your micro operation, it will have your F1, F2, and F3. And you can see under your select, you're going to have your CD and BR. The control memory has 1024 words. So from here, you will convert it. You're going to get to the power of 10. So this 10 means that you have 10 bits for each word. For each word, you have 10 bits. Select fields consist of status bit and also branch bits. How you going to get the selection bits? This one, it is from this value. This one you can see you have total up is 10 bit, and you have 32 bits. You already occupy 16 bit for your micro operation, and now you have another 10. Your bits will be 6. Okay, that is on your selection field. How many bits? So now you already see you have 3, 16, 6, and of course the rest is will be 10 for your address field, because it already shows you the address field is 10 bits. So altogether will be 32 bits. From just this instruction, you can draw this like format header for your micro operations. You can put it as 6, 10, and 16 based on what have ever given here. And after that, you have several others tasks. Task A, task B, task C. How you're going to define it? Okay, this one is your micro operation, and this one your address, as I already shows you. How many bits are there in your branch address field? And the selection field, this one also we already answer it, because our address field, how you going to see, you have the word is 1024, and you convert it into 2 the power of n. This N is your address bit. How many address bit that available? So you're going to see that it is to the power of N. Same goes last time when I want to see how many bit. Mana I dah delete Okay. Like this one, if you have 3 bit, you're going to put how many possibilities to the power of N. This N will be putting the value of bits, right? So your possibility is going to be how many operations that you have in F1. You're going to have to the power of N equal to 8. Now, if you have to the power of N equal to 1024, what is the bit? Then you are having the vice versa. That's why you're going to fill in your address later on, depend on the question. So that's why it is a red color over here. You have to the power of N, and here is 10. So you have 1024 operation, and you're going to have 10 bits. Okay, so this one you already answer, and of course when you know 32 bits and 16 plus 1, you're going to get your selection field for your CD and also BR. You're going to get 6 bit. So if there are 16 status in your system, how many bits of your branch logic are used to select the status bit? See this one also, you can see 16. Normally you're going to have to the power of N. For the status, you want to see the status, how many bits that are available. So N, you will get to the power of 4, you will get 16. So this is the bit for the status. So all similar. If you have, this is for your address, you're going to have to the power of N also equal how many, and this N is the bit. So you have 16 status, 16 operations, 16 possibilities. How many? And you have, which is 4. That's why you have 4 bit for your status system. For your branch logic. And another one is in your how many bits are left to select input for multiplexer. So if you calculate, you have 16 for your micro operation. You have address is 10. You have the selection 6, and you have another one for your branch BR. For your BR is 4 bits. So all together, how many left? So you will get 16, 10. Already more than that. 20 plus 16. I calculate this correct or not? 16 plus 10. And then we have 4. We have 16, and then we have 10 for address. And the left,
it's 9 hours.
Oh, inside your selection. Sorry, I forgot this one. Okay, this one is your selection field. Kenapa pula I lupa? Okay, in your selection, you have branch and also your CD. So your branch tadi you dah ada 4 bits. All together in your selection, in your selection, all together is 6 bit. Then because of that, you have the CD and also your BR. So your BR, your branch is already occupy 4 bits. How many bits that available? You're going to have 6 minus 4 equal to 2 bits. So this is kind of question for calculation that can be asked in terms of your addressing, uh, your branch, and so on, F1, F2, and F3. So throughout all of this, you can conclude the advantages and disadvantages. So you're going to see the advantages and your disadvantages for your microprogram. Because in the beginning of our slide, you can see that we know our microprogram is the solution if you want to find a solution for your problem in your hardware. In your hardware program, a lot of other disadvantages. So that's why you're going to use and come out with your microprogramming. But still, anything will be having a pros and cons. That's why you're going to see the advantages and disadvantages. For advantages, you can see simplify the design. Of course, if you compare with your sequential circuit, if you have sequential circuit, you're going to have like a complex of your circuit. If you want to add one circuit also is really complex, especially when you are doing digital logic. You know how hard for you to come up with a single sequential circuit, how you're going to connect and so on. But in terms of programming, if you want to add something also, it's going to be slightly simple rather than having the sequential circuit. Those it is both cheaper, which is less error prone to implements. Cheaper means that you just do in typing your programming, you add another blocks of programming and you another modules and so on. But if you are using hardware, of course, you need to buy your gates, you need to buy a flip-flops and any others digital logics, digital elements that you need to buy. It's going to be increased in the cost. So for microprogram, it's much cheaper and less error because if you have short in your sequential circuit, then it's too easy to get error. If you have error, then it's hard for you to find where is the error in your circuit. And a third advantages is it is the decoders and sequential logic unit are very simple pieces in logic. Is it simple? It's slightly simple, I guess, but it's not too simple because we still have a problem with that. And disadvantages, you're going to see it is a slower. So only one disadvantages is might be slower than if you compare to hardwire. But actually, if you run your programming, you cannot see what happened, and you will just see the output, and you think that, oh, your Visual Studio is very fast. So again, let's say in a blink of eyes, you can get the output. But actually, in let's say nanosecond, it's still slower if you compare to your hardware. So we're going to conclude what we have learned. So you can see, explain the concept of micro operations, define the principles instruction cycle throughout what we have learned, and then you can see that we already discussed how macro operations are organized to control a processor and understand hardwire control unit organization. You dah faham or not all these three summarization? If you are still not, then you need to check back the videos and try to do a study on that. And you can try to answer the review questions that given. If you can answer means that you understand all. So now you already finished your module 5. I guess although it is not cover in your test too, but maybe you can also have like 1 hour for module 5, and then the rest you can do for your test 2. So maybe you can also put in which one is priority, but don't put the priority too much until whatever you are doing it in now parallel simultaneously currently you're going to be lost. So please to specify and arrange your time well. So we're going to continue with our module 5. Kenapa tiba-tiba kat sini? We're going to cover only a bits part which is on the early starts your instruction, more on theory of course. For your 6.1, your introduction. Oops. Okay, we're going to start our module 6. You will look into memory. In module 5, you look into your CU, control unit. Now we're going to look deeper in your modules memory. If you talk about memory, of course, when you want to buy a laptop or a computer, you always heard about RAM and ROM. Then after this, is it you're going to find a similar, your basic things that you understand? But I guess many other things that you're going to find out later on throughout your module 6. So first we're going to look into the introductions. What we'll cover is overview, type of memory and the memory hierarchy. Kalau yang bosan dengan sejarah ni nak tengok hierarchy, so you feel like it's very bored. So the overview, you know in your first module about this von Neumann. Your von Neumann model is of course for your computers, the earliest computers, which is centers of memory. It's called it's build your computer and is centered on a memory. The program that perform the processing are stored in your memory, in the memory. So this model if you have a program, you're going to store it into memory. The memory unit that communicate directly with CPU called as main memory. Last time, I guess you already know you have a main memory, you also have a secondary memory. Mostly you will use this name, main and secondary. But you can see over here later on, you still have a main memory. And let's say you can see this memory is the one that direct connect your memory to your CPU. It's called as a main memory. And only program and data currently needed by processor will be resided in your main memory. Kalau yang tak diperlukan waktu tu, it's not in your main memory. So devices that provided backup store. So you have a backup store. It's called as auxiliary memory. Now you have a new term of your memory. Device that provide backup store called as auxiliary memory. You also have internal memory. Oh, banyaknya main memory, you ada internal memory, you ada auxiliary memory. That's why I mentioned to you last time, maybe you have about memory, you have a RAM and ROM only. Now you go deeper and deeper, you find out there are many others that you are not knowing. For your internal memory, it's often equated with your main memory. But there are other form of internal memory also. So you can see there is a lot inside your, let's say you have a memory. You have main memory. You have, oh, this one is a device. But it's okay, I just put over here, okay? So that you can understand it is in the memory category. Auxiliary memory. And you have the internal memory. Inside your internal memory, you can have several others memory. First, you're going to have the register. This one is like a type for your internal memory. First is a register. Register is the processor required on the local memory. And then you have a control memory also. It is another type of your internal memory. And another one is your cache, is another form of your internal memory. You have three: cache, register, control. So I guess a lot of new terms about your memories are learning by today. The complex subjects of computer memory is made more manageable, which is we classify as a memory system. According to their key characteristic, which is you can see the tables. This is the table. Key characteristics of your computer memory system. There are a lot, but you're going to see all the functions. If for location, what is type of memory that you're going to deal with? If capacity, if unit transfer, access mode, performance, physical type, physical characteristic, and organization. So this is all the memory system. There are too many, but sometimes you can see over here it is external, internal, external. What type of memory that you need for each of characteristic. Maybe you can go through all this table and learn it, what basically memory that you are using in your specific program. So type of memory. Why there are so many different type of computer memory? Now you're going to see you have many type of memory. So the answer, new technology continue to be introduced in attempt to match the improvement in your CPU. When you want to improve, you give and introduce new memory. So you have new memory, is become bigger and bigger, is become many. So that's why you will look like, oh, it's too many of memory that you need to memorize. Even though a large number of memory, but you can divide it into two type memory only. Now you can see your normal terms, which is RAM and ROM. RAM is random access memory and ROM is your read-only memory. Daripada you pusing-pusing tadi, you can see you need to learn on main memory, auxiliary memory, internal memory. There are too many also, like register, control memory, and cache. And this is also a characteristic for your memory. You're going to see like, wow, there are too many. But because of that too many, you can divide it into two main scope, your RAM and your ROM. Under your RAM, it also is also your main memory or your primary memory. Yang tadi mula-mula at the beginning of the slide, you are looking into main memory, which is the one that directly connect and communicate with your CPU. Oh, now you know, oh, this one is a RAM. This is the RAM and also can call as main memory, or it can also call as a primary memory. However, RAM is volatile and also loose. These information, once the power is turned off, let's say, I give you example, you you are doing some programming, or you open a program, and then all the data that you save is directly saved to your RAM. But when you turn off your computer, all the data will be deleted. All data will be lost. The organizations of RAM is the key design issues, refer to physical arrangements of bit to form words. So that inside your RAM also you can divide it into two, which is SRAM and DRAM. SRAM is static random access memory and DRAM is dynamic random access memory. Okay, you can see that is for your RAM. You have SRM, SRAM and also DRAM. Later on, of course, you're going to go deeper and deeper for all of this. But just stick until here first, which is you have your RAM and you have two big, this one is memory. You can specify it into RAM and ROM. And then under RAM, you have SRAM and DRAM. Now let's take a look what is inside our ROM. Are we going to have several others? Same goes to RAM. Okay, now ROM is read-only memory. Store critical information necessary to operate the system, just as a program necessary to boot the computer. So program yang need to boot computer are stored in your RAM, in your ROM. ROM is not volatile and always retains its data. Maintain information when power is shut off. So normally, if you have a multiple choice question, you're going to see they will always ask about this question. Which of the following of the memory, Allah, apa nak join ni? Okay, you can see over here. Some and mostly the question will ask, it gives you a description about whether your information or your data are there and safe after you shut down your computer or not. So normally this kind of question. So if you shut down your computer, what type of memory that still hold the data? So it's normally a ROM. That is many questions will coming out asking a similar things. I don't know why. Maybe this is the big differentiation between a ROM and also RAM. ROM is not, okay, this one is already. Some different type of ROM. Tadi you ada memory. You already have memory. You can divide it into RAM and ROM. Then you can divide it into SRAM. Another one is DRAM. And ROM, there are more others, which is PROM, EPROM, EPROM, and lastly your flash memory. So what is PROM? It is programmable ROM, the one that you can reprogram in your computer, which is your program you can reprogram. And then EPROM is erasable PROM, the one that you can erase from your PROM. And EEPROM is electrically addressable PROM. And lastly, your flash memory. This one is a normal terms that you always heard, which is essentially EEPROM with the added benefits. So what is the benefits of flash memory? Rather than if you compare to EEPROM, later on you will see. Okay, that is about your memory, RAM, ROM, and what how you're going to define your RAM and ROM, and maybe you can differentiate it between several other specification and type. Now you're going to see the memory hierarchy. If you can see, generally speaking, faster memory is more expensive. You will always see when you want to buy laptop, you want to buy computer, when you have higher in your memory, your RAM and also your ROM. If you look much higher, it's going to be more expensive. Then if you compare to low memory, of course the price for the laptop and also for the computer is much lower. Provide the best performance at the lowest cost. Memory or organized in the hierarchical fashions. Small fast storage elements are kept in the CPU, which is large, slower memory is accessed through the data bus. Larger, which is almost permanent storage in the form of disk and tape driver, is still further from your CPU. So this one, fast storage, which is your memory storage and also element are keep in your CPU if you compare the one that's slowest. Larger and slowest memory is accessed through your data bus. It is not going to be directly inside your CPU. It's going to be burden your CPU, of course. But your CPU can always connect to them, can communicate and can to drag also to the slower and also large memory throughout your data bus. And your permanent storage in terms of form of disk and also tab driver, your pen drive is further from your CPU, of course. When sometimes you have external memory, of course it is not inside your CPU. So this is the memory hierarchy. What you have for your memory. In terms of that, you can see first of all you have register, and then you have level 1 cache, level 2 cache, and then memory, fixed rigid disk, optical disk, and lastly your magnetic tape. This one I think like a floppy disk. Optical disk is like your CD and so on. Okay, you can see how fast it's going to be increased in the time, and also the cost also will be increased. Much higher for the hierarchy in your memory, it's much cozy. And you can see there are several others like offline. Normally this one is offline because you have floppy disk. You can always disconnect from your PC. And nearline for your optical disk, online for fixed rigid disk, and lastly all others of this is inside your system. So you can see over here what is the specification for your RAM, which is divided into your SRAM and also your DRAM. You can see your employed in the semiconductor technology memory. You have this one, and above is your SRAM, and this one is your DRAM. You can see also over here the hierarchy. How about your CPU? Whether it is inside or much further from your CPU. To access the particular pieces of data, the CPU first send request to the nearest memory, usually your cache first. So from your CPU, you're going to send step by step which is the nearest to get, let's say, any kind of data. That's why you can see longer in place, you're going to have longer in time. If you look into register, same goes your Visual Studio. You just look into your EAX, your EBX, and etc. It is your register, right? So it is nanosecond. That's why in a blink of eyes, you can just get your output. Sometimes when you want to open your CD, you're going to have like loading. You're going to load first. So it's take times. So sometimes it's going to be taken in second. So that's why you can see it. Because your eyes, our life is in second. But if nanosecond, our normal eyes cannot see it unless, I tak ingat lah nama apa, Carl X1. Saya suka tengok cerita ni, Carl X1. Maybe kalau you tak pernah tengok, you tengoklah. Lelaki ni handsome, perempuannya, heroine dia sangat cantik. So dua-dua ni looks like macam baik sangat. And KS1 ni dia boleh tengok lah program tu berjalan semua dengan slownya dan dia boleh hafal semuanya. But for normal person like us, we cannot see basically when you open this slide. You can see move from here to there. And next slide, we cannot see basically what is happening because in a blink of eye, we can directly see, okay, it changes on the pages. It changes to the next pages and etc. But basically in nanosecond, there are something happen. We fetch the information. So in a blink of eye, we can see only it's moving. But for your car as well, of course, he can see before it's load what is numbers of your 1010 machine's language and so on. So duduk rumah tu pergilah cari ni car as well. Best sangat. Saya rasa mungkin attract to the face first, then the story also is very nice, so I guess that's why I like it. And now you can see over here, if the data is not in cache memory, which is then add your main memory. If the data is not in your memory, then you're going to request to your disk. So that's why it's going to be flow by flow. Once the data is located, once you find it, then the data and a number of it nearby data elements are fetched. So you're going to fetch the data and the element into your cache memory. You ambil, contohnya you nak ambil perkataan F aja dekat your optical data, contohnya in term of ones variables, then you're going to send it to your cache until go to your CPU, so it's to be read. The following terminology is used when you are referred to your memory hierarchy. Saya duduk ni. Okay, you can see over here you have the terminology which is hit, miss, hit rate, miss rate, hit time and miss penalty. Kalau tengok ni saya macam apa benda ni miss penalty? Maksudnya saya sepak gol tak masuk. So all of this in term of computing statement, computing terms, tak ada kaitan dengan football ke apa-apa lain, tak ada kaitan. It is on your memory terms. So there is a specific for all, like hit. What is basically hit for? Hit is the data is found and given a memory level. So all of this you can read. Kalau saya baca je slide ni macam tak guna juga kan. Bukan you dengar pun, if I baca it's going to be boards. But all of this is the definitions you need to know for all of the terminology given in the table. Because sometimes maybe you will ask with the question, what is the process for misread? So you need to explain it. If you understand, then it's easy for you to organize your own sentences. So logically of references, but I guess for your part B, last time, if face to face exam, normally in term of every part, like part A of course is going to be asked in more in theory, but part B normally also is going to have some introductions question on top of before you go deeper, which is harder question, of course, if compare with part A. You're going to have like a small part, maybe 3 marks about definitions. So you need to write it on your own words. But now I don't believe that this is exist anymore, especially for COA subject, which is they plan to have all under e-learning marking. So I don't know, but it is not yet decided. So officially, will be announced later. So logical, logic, local locality of reference. Entire block of data is copied after a hit. You can see after you hit, you're going to copy an entire block of data, because the principles of locality tell us that one a bit is accessed once you dah jumpa, when you dah already found, kan you ada hierarchy tadi macam ni. You nak find the F, you go to your cache, you go to your memory, you go to the disk, then baru you jumpa. When you jumpa, you going to hit, found. After you found, then you going to tag the entire data. I just give you example, you nak tarik ni sahaja, right? So when you hit, it means that you can access it, and this is throughout your principle of locality. It is likely that nearby data element will be needed soon. So there are 3 basic form of locality: temporary locality, spatial locality, sequential locality. So what is temporary locality do? Is recently accessed item tend to be accessed again in next future. Contohnya apa benda yang you some things that you need to use again and again after that. So it's going to be saved in your temporary temporal locality. So for facial locality, assets tend to be clustered in your address space. Under your address space, you're going to save it and push it into your special locality. And for your sequential locality, it is instruction 10 to be accessed sequentially. That is on your locality. So that is the only introduction part for your module 6. So maybe you can try those questions, answer those questions if you already done go through all in your 6.1. So in our next class, we're going to cover the rest of others. But of course, my priority for our next class is on our test 2. So I hope that all of you can give your test 2 also priority. But on top of it, don't miss the video that I share in your e-learning. So is there any question?
Good morning, doctor.
Yes.
Sorry for interrupting, doctor. So I want to discuss some little bit serious issue with the doctor regarding the my group mate.
Okay.
Yeah, because it is a offense. It is considered as an offense. So okay, my group
Wait,
mate is
wait,
yeah.
I stop recording first.